Okay, so here in this topic, we'll be learning about using Apache Spark in Microsoft Fabric. So let's get started. Okay. So, as we know about Apache Spark, that it is often used in conjunction with a data lake architecture to process and analyze large volumes of data stored in the data lake. Okay, and we can use Spark in Fabric to continue transforming data or to build a machine learning model. So Apache Spark, it is distributed data processing framework that enables large-scale data analytics by coordinating work across multiple processing nodes in a cluster. Okay, and we can put it up more simply that the Spark, it uses a divide and conquer approach to processing large volume of data quickly by distributing the work across multiple computers. Okay, and the process of distributing tasks and collating results is handled for us by the Spark only. So you can submit a data processing job in the form of some code that initiates a driver program which uses a cluster management object called a Spark context to manage the distribution of processing in the Spark cluster. In most cases, these details are abstracted and you just need to write the code required to perform the data operations you need. All right. Then Spark, it can run code within a wide range of languages, including Java, Scala, Spark R, Spark SQL, and PySpark. Okay. And most of the data engineers and analytics workloads are accomplished using a combination of PySpark and Spark SQL. Now, if we talk about the settings, so in Microsoft Fabric, each workspace is assigned with a Spark cluster, and an administrator can manage the setting for Spark cluster in data science or data engineer section of the workspace setting. All right, here we can see. And if we talk about the libraries, so Spark open source ecosystem, it includes a wide section of code libraries for common and sometimes very specialized tasks. And since a great deal of Spark processing is performed using PySpark, a huge range of Python libraries ensures that whatever the task you need to perform, there's probably a library to help. All right. So this is how you can prepare to use Apache Spark. Now let's move ahead. Okay. So how to run Spark in Fabric. Now, to edit and run Spark code in Microsoft Fabric, either we can use notebooks or we can define a Spark job. So, while running a Spark in a notebook, when you want to use Spark to explore and analyze in data interactively, use a notebook because notebook enable you to combine the text, images and code written in multiple languages to create an interactive artifact that you can share with others and collaborate. Then notebook, it consists of one or more cells, okay, and each of which can contain markdown formatted content or executable code that we have already seen in our last demonstration. Okay, you can run the code interactively in the notebooks and see the results immediately. You can also define a Spark job. So, if you want to use Spark to ingest and transform data as a part of an automated process, you can define a Spark job to run a script on demand or based on a schedule. To configure a Spark job, create a Spark job definition in your workspace and specify the script it should run. You can also specify a reference file, for example, a Python code file containing definitions of functions that are used in your script, and also a reference to a specific lakehouse containing data that the script processes. Okay. Now let's move on and see how can we load the data in Spark data frame. So working with data in a data frame within a notebook, it combines the interactivity of data exploration, expressive data manipulation capabilities, visualization, collaborative analysis, interactive development, and documentation in a single environment. Natively, Spark uses a data structure which is called Resilient Distributed Dataset (RDD). But while you can you can write code that work directly with RDD. The most commonly used data structure for working with structured data in Spark is the data frame. All right, and this data frame is provided as a part of Spark SQL library. Data frame in Spark are similar to those in the Pandas Python library, but optimized to work in Spark's distributed processing environment. Now, while inferring a schema, suppose we have a delimited text file named as product.csv. Okay. Um, in the file and data folder in your lakehouse, and in the Spark notebook you could use the uh, mentioned PySpark code to load the file data into the data frame and display the first few rows. Okay, this data frame, it includes standard functionality for transforming the data. Then you can also specify an explicit schema. Okay, so in the previous example, we can see that first rows of CSV file contain the column name, and Spark was able to infer the data type of each column from the data it contained. But you can also specify an explicit schema for the data, which is useful when the column names are not included in the data files. All right. So this code represent how can you explicitly specify the schema for the data. Okay, so now let's move on to the next slide. So now we have loaded the data. Now it's time to transform the data in Spark data frame. Okay. So data frame methods basically are the functions or operations provided by a data frame object that allow you to manipulate and analyze data stored in the tabular form. Okay, and you can use the methods of the data frame class to filter, sort, group, and otherwise manipulate the data it contains. Okay, so for example, here the code which is given here, it uses the select method to retrieve the product ID and the line item total column, okay, from the df frame data frame containing product data. Okay, we can also chain methods together to perform a series of manipulation that results in a transformed data frame. So for example, this example code here, it shows the code chains the select and the where method to create a new data frame containing product ID line item column for product with a quantity of 1 or 2. All right. Then inside the notebook, you can also group and aggregate the data, and for that you can use the group by method and aggregate functions. Okay, so for example, here this for PySpark code, it counts the number of products for each quantity of orders. All right. Now, you will often want to use Spark to transform raw data and save the results for further analysis or downstream processing. So, the code example here, it saves the data frame into a Parquet file in the data lake, and it is also replacing any existing data with the help of override um, uh, method here. All right. So this was about transforming the data. Now let's move ahead and look into the partitioning. So how can we partition the output file? So partitioning is an optimization technique. It enables Spark to maximize the performance across the worker nodes, and more performance gains can be achieved when filtering the data in queries by eliminating unnecessary disk I/O. So to save a data frame as a partition set of file, use the partition by method when writing the data, and the following code example, it saves the data frame and partition the data by year. Okay. Now loading the partition data. So when reading partition data into a data frame, you can load the data from any folder within the hierarchy by specifying the explicit values or wildcards for the partitioned field. Okay, so this was about partitioning the output file. Now, how to work with data using Spark SQL. So, the data frame API, which are a part of a Spark library named Spark SQL, which enables data analysts to use SQL expressions to query and manipulate data. Okay, and creating a database objects in the Spark catalog. So Spark catalog, basically it's a meta store for relational data objects such as views and tables, and Spark runtime can use the catalog to seamlessly integrate code written in any Spark supported language with SQL expressions, and that may be more natural to some data analysts or developers. So one of the simplest way to make data in a data frame available for querying in the Spark catalog is to create a temporary view. All right. So a view is temporary, meaning that it's automatically deleted at the end of the current session. You can also create tables that are persisted in the catalog to define a data set that can be queried using Spark SQL. So tables are metadata structure that store their underlying data in the storage location associated with the catalog. And in Microsoft Fabric, data for managed table is stored in the table storage location, which is shown in your data lake. And any tables created using Spark are listed there. All right. You can create an empty table by using spark.catalog dot create table method. Okay, or you can save a data frame as a table by using its save as table method. Deleting a managed table will also delete its underlying data. All right. And we can use the meta store to define tables to create a new table based on the data files in an existing folder. So we can use an external table to save the data frame as a new set of data file in a location other than the default table storage. All right. So this is how you can create an external table. Now let's move ahead and look at how can we query data using Spark SQL API. So you can use the Spark SQL API in code written in any language to query the data in the catalog. Okay. So the displayed PySpark code, it uses a SQL query to return the data from product table as a data frame. Okay. And in a notebook, you can also use the SQL magic, okay, to run the SQL code that queries object in the catalog. All right. So either you can use a Spark SQL API or you can directly use the SQL magic to query the objects. So this was about querying data. Now let's see how can we visualize the data. So one of the most intuitive ways to analyze the result of data query is to visualize them as charts. So notebooks in Microsoft Fabric, it provides some basic charting capabilities in the user interface. And when that functionality does not provide what you need, you can use one of the many Python graphic libraries to create and display data visualizations in the notebook. Okay. So here you can use built-in notebook charts. So when you display a data frame or run a SQL query in Spark Notebook, the results are displayed under the code cell. By default, results are rendered as a table, but you can also change the result view to a chart and use the chart properties to customize how the chart visualize the data. Or you can also use a graphic package in the code. So there are many graphics package that you can use to create data visualization in code. Okay, and in particular, Python support large number of selection of packages, and most of them built on the base Matplotlib library. So the output from a graphics library can be rendered in a notebook, and it makes it easy to combine code to ingest and manipulate data with inline data visualization and markdown cells to provide commentary. Okay, so with that, we have a exercise or a demonstration here as well. So let's move ahead with that. Okay, so let's start with our demo. And in this demo, we will analyze the data with the Apache Spark. Okay, so first of all, we will create a workspace inside our Synapse data engineering section. So We'll select workspace from the left hand side menu bar and we'll create a workspace. Okay, so now we can see that workspace has been created. Now inside it, we will create a lake house and we will upload some files in it. So I will go on Synapse Data Engineering homepage, select lake house and create. Now we will ingest some data into the data lakehouse for analysis. Okay, so for that, I will be downloading some file. So let me just copy the link. All right, so I have downloaded the file and also extracted the data files. Now, after that, I will come back to the Lakehouse Explorer and from the files folder, I will be creating a new subfolder. Rather, I will go and I will upload folder. Okay, so this time I will be uploading whole orders folder here. So this folder contains 3 CSV file. Okay. Now if I click on my orders subfolder, I can see 3 CSV files. Now I will be creating a notebook. Okay. So for that, I will from the home tab, I will click on open notebook and will select new notebook. Okay. So here, this is the first cell and let me just switch it to the markdown cell. Let me just edit it and I will write sales order data exploration. All right. Okay. So now I will in the orders, I will select the orders folder and now from the menu of 2019.csv file, I will load it to Spark. Okay, so I can see that our table is loaded in the Spark and now we are loading this file in a data frame basically, right? So let me just run this cell. Okay, so now we can observe that the rows and columns are getting displayed by this command by these commands and we can observe that the header basically it is taking the first row of the csv file, it is assuming it as header. So now let us just modify the code and make this true as false so that it will not consider it as header. First true as header. Okay, so now we can see that we have some random column names, but it is not it these are not very helpful. So to make sense of the data, we need to explicitly define the correct schema and data type for the data values in file. So we will modify the code, all right, or rather I just add a new code cell and I will explicitly define some uh, column name. So for that, I will copy and paste the code here. So now let's run the cell. So here basically we are giving the column names. Okay. So now we can, in the output, we can observe that it include the correct column name. All right. And data types of the columns are specified using a standard set of types, which are defined in a SQL, Spark SQL library, which we have imported here. Okay. So now let's confirm that the changes have been applied to the data by viewing this data frame. So let's display the data frame. Okay, let me run it. Okay, so we can see the same result. Now, so far we have do it for 2019 .csv file. So let's modify the code and let's use the wildcard character instead of just 2019. So let's go back. Okay, and instead of just 2019, I will here use the wildcard character. Okay, now I will run it. Okay, so if we observe, we can observe that it has been done for all the files. Okay, for that we need to scroll down. So it is bringing data from all the files. Okay, now we'll explore the data in a data frame. So for that, let's add one more code cell. And in here, let me just copy some code. Okay, for exploration of data. So here a customer data frame has been created and it is also counting the distinct values of the customers. Okay, and basically this is used to summarize and filter the data that is contained by the data frame. And if you observe with the data frame, we are using a shortcut way of defining subset of columns. Okay, and so we'll modify it, and let's see, rather than just using uh, this shortcut, we can also modify the code as. So here we are using select method, uh, and we are selecting the specific columns. Okay, so let's just run it. So here we can observe. So here it is bringing only we are able to view the customers who have purchased this item specifically. Okay, so we have applied a filter here, and we also used select method. Now let's see how can we aggregate and group the data in a data frame. So for that, let's again add a code cell. Okay, and let me just copy the code. Okay, so here we are grouping the data as per the items. So it is showing the result of order quantities which are grouped by product, and group by method here grouping the rows by item, and the subsequent sum aggregate function is applied to all the remaining numeric columns. Okay, now let's add one more code cell, and let me run it. Okay, so here select method, it includes the SQL year function. All right, and this year function is extracting the year component of order date field. All right, and then we use LES method, and it is used to assign a column name to the extracted year value. Then the data is grouped by derived year column, and the count of the rows. We are also counting the rows in each group. Okay, so this is how you can explore the data. Now, not just exploration, but you can also use Spark notebook for transforming the data files. Okay, so for that, let's just add one more code cell. Let's see the result. Okay, so here what can we observe? That we are adding the year month columns based on the order date. Then we are also adding first name and last name column based on the customer name. You can view these commands. And then we are filtering and reordering the columns, and we have removed the customer name column. And after that, we are displaying the first 5 orders. Okay. All right. Now we will save the data frame. Okay. So again, we will add a new code cell for saving the transform data frame in Parquet format this time. All right. So we can see that transform data has been saved. So to check that, we will refresh the file folder and we can see a transformed order folder here. Okay, and let's just verify that it contains the Parquet files. Okay, you can observe it. Okay, now we can add a new cell. Okay, and after that we can load the data frame from the Parquet file in the transformed order and orders folder. Okay, so let's do it. Let's add a new code cell. And here, let me just, okay. So if we observe the data here and we'll refresh. Okay, so now it is basically, it is what is it doing? It is showing loading the order files data in the order underscore df data frame and displaying the result. Okay, now we'll save the data in the partition files. So for that, we will add a new code cell. And let me just copy paste the code. So now again, if we refresh, okay, let me refresh it again. Let me refresh files. So here now I can see partitioned data folder. And if I just explore it, I can see that data has been partitioned in the folder named according to the years, and each year folder is containing the month folder. Okay, so each month folder then contain the, if I just explore it, each month folder contain the Parquet file. Okay, so this way we can partition the data files, and basically it is helpful in optimizing the performance when we are dealing with the large volume of data. So now we can add a new code cell, and let me just add it. And So basically, we are loading a new data frame from Parquet dot from orders dot Parquet file. Okay, you can observe it. So this is how we can work with the Spark notebook in our fabric, and we can do a lot many things, like we can also work with tables in SQL. We can visualize the data with Spark, and we can also create some graphical visualization using Matplotlib, and so on. So this was it with the lab. Rest of the things you can do in the homework. So now let's